All right, this next slide is like a bunch of examples, and I'd rather do these in class or have you guys try them on your own between now and then we'll look at the answers you guys got. Um, there's like there's like a couple of things to do here. First, say whether the original statement is true or false. Then write the converse and say whether that's true or false. And if you think it's false, you need to give me an example that proves that it's false. Maybe I'll do the first one just to give you, so you guys know what I want you to do here. So if two angles are right angles, then they are congruent. Well, that's true because right angles each measure 90 degrees. Every right angle measures 90 degrees, and two angles that measure 90 degrees are definitely congruent to each other. So this statement is true. Its converse is if two angles, that's a symbol for angles, are congruent, as a symbol for congruency, then they are right angles. This would be the converse. I switched the congruent was first the hypothesis, now the conclusion, now it's the hypothesis. The two angles being right angles was the hypothesis, now it's the conclusion. This statement, this is the answer to the first part. This first statement is true. I'm gonna put that over here. It's confusing me. I feel like that makes you think that second one is true. So this is true. But this is not true. Two angles are congruent and they're right angles. That's not true. There's a lot of angles that are congruent that aren't right angles. Here's a 40-degree angle, and here's another 40-degree angle. Are these angles congruent to each other? Yeah, they both measure 40. But are they right angles? They are not. These angles are 40 degrees, and right angles measure 90 degrees. So I've satisfied the hypothesis, two angles are congruent. That's what this is. But I did not satisfy the conclusion. These are not right angles. So this is like I said whether it was true or false. I wrote the converse and I showed that it was false. Some of these might have true converses. But actually I think all of these are false. So you should be able to find, the second one's not false, but the other ones are false. So you should be able to find counterexamples for 3, 4, and 5. Nope, just kidding. 2 and 3 you won't be able to find, but 4 and 5 you should be able to. Okay, so sometimes the statement and its converse are both true, and when that happens, we call that statement biconditional. Think of it like this means this usually means two, the prefix bi, like biped or bicep. Bicep must has two heads. But a biconditional statement is like one where this is where the statement and its converse are both true. Meaning if you switch the hypothesis and conclusion, you get a true statement both times. So it's called a biconditional. We usually use this, it's almost always used with this phrase, if and only if. That means biconditional. And definitions are always biconditional. We saw one of these, I'm going to skip back a couple slides here. Like right here, if a number is divisible by 2, then the number is even. That works both ways because the definition of an even number is that it is divisible by 2. So anytime it's a definition, you're going to have it, it's going to work both ways. The statement and the converse are both going to work. So we'll probably have an example or two here, I would guess. Here you go. Here's a right angle, or here's a biconditional. It says write the definition of a right angle, which is what this is. This is the definition of a right angle. A right angle is an angle that measures 90 degrees. We know them from pictures. They look like this. This is a right angle. They always measure 90. This is a definition. And you can say this, an angle is a right angle if and only if it measures 90 degrees. This expression, if and only if, is your cue, is your hint. This means biconditional. Whenever you see if and only if, you know you're going to have a biconditional, meaning a statement that should be true both directions. And this, the two directions are, an angle is a right angle if it measures 90, that's true. And the other one is, if an angle measures 90, then it's a right angle, that's also true. And when that happens, we have what's called biconditional, meaning it works two different ways, both directions, two directions. And it usually means that it's a definition. In this case, it is. This is the definition of a right angle, can be written as a biconditional. So we already talked about this. This is the original, the conditional statement. The converse is when you just switch the P and the Q. We talked about that. And now we have these other two. And there's something besides just switching these, you can do what's called negating them. Negations. So like, instead of saying if P then Q, this thing that's called the inverse, which is our third type of statement, says if not P, then not Q. This not P means like, this means the opposite of P. So like if the P here was if a number's even, then if not P would be if a number's not even, or we know that means if a number's odd. And if then Q was a number is divisible by 2, then not Q would be a number is not divisible by 2. So you can always put you can usually just put the word not in front of it and it works. But things like even and odd, there's only one, numbers can only be even or odd, they can't be anything else. So besides just taking the hypothesis and the conclusion and switching them like we did here, we can also take the hypothesis and conclusion and negate them. Make them not this, then not that. And we can see if that's true or not. And there's some value to doing this, I promise. And the last thing we can do is what's called the contrapositive. That's a long name. But it basically means like, instead of just switching Q and P like we did for the converse, we switch them and we negate them. So this is like so our original statement was if P then Q. So if I switch Q and P, so Q first, P second, and then I also make them not Q and not P, I get what's called a contrapositive. The contrapositive is interesting in the sense that if the first statement is true, then the contrapositive must also be true. I'll say that again. If the original statement is true, then the contrapositive is also true. And if the original statement is false, then the contrapositive is also false. We would say that the conditional and the contrapositive have the same truth value. Meaning whether if one's false, the other's false. If one's true, then the other is true. And that can be useful when we're trying to prove statements true or false. Truth value. Sometimes it's called a Boolean value, but we'll call it a truth value. So we're almost to the end of this, thankfully. So now they want us to write all three of these things. So it's good to identify the hypothesis and the conclusion first. So if something, then something, that means this is the hypothesis. And this, what am I doing it in green now? Then this is the conclusion. Remember, the if and the then aren't a part of the hypothesis or the conclusion. They're just there to connect the two of them. So the converse, if you flip back, you'll see that just means you switch the hypothesis and the conclusion. So I say if M is the midpoint of AB, then AM equals MB. This would be called the converse. I abbreviated it conv. So that's a converse. If you scroll back a minute and you'll see that the inverse means that you just take the original things in the same order and you just negate them. So if AM is not equal to MB, this is now the negation of this. It's the opposite. This said it was equal. I said it's not equal. And now I need to negate the second one too. Then M is not the midpoint of AB. So let me just scroll back for a minute and check that. So the inverse said not P, then not Q. So same order as the original, but both opposites, both negated. So I look, and if it's the same order, AM and MB, and M is the midpoint, but I changed them from equals to not equals, and from is the midpoint to is not the midpoint. And now I have what's called the inverse. And now I have the last one's a contrapositive. Contrapositive. That means I switch the order of these two statements and I negate them. That says if M is not the midpoint of AB, then AM is not equal to MB. So this is called the contrapositive, and it's where I switch the two statements and I make them and I negate them. I make them the opposite. So if M is not the midpoint, then AM is not equal to MB. That's how you write these. This is like a really easy test question for me to make, or quiz question. I just give you a statement and I say, write all three of these things. And you have to write these down. I encourage you to make sure that after you've written them down, you read them to make sure that they sound like actual sentences. This is a sentence. If M is the midpoint of AB, then AM equals MB. And this is also a sentence. If AM is not equal, then M is not the midpoint. It's like, I've noticed that students often will just like write things between for, if, and then without changing any of the words, and make it so that it's like a meaningful sentence, please. You notice the if and the thens are in here, but they're not part of the conclusion or the hypothesis. And that's good because here I want the then in front of AM equals MB, but the if was in front of it up here. So just be aware. You don't have to worry about the hypothesis is this, the conclusion is that. I can do this, right? M is the midpoint is here. M is not the midpoint is here. M is not the midpoint is here. Right? Those are all the conclusions, and they're sometimes they're negations. So you can see that the blue one goes where the blue one goes, and the red one goes where the red one goes. So last but not least, and this is what I said before about the original statement and its contrapositive are always both true or both false. That's talking about the truth value, as in, is it true or is it false? And for the original is contrapositive, those are always the same. The original is true, contrapositive is true. If the original is false, the contrapositive is also false. Okay. So now this is like the whole thing. Write the if-then form of the following statement and write the converse, inverse, and contrapositive, then decide if your statement is true or false. Okay. If-then. If, this is like a little, sometimes this is where kids get a little lost sometimes. They're like, well, how do I turn this into an if-then statement? You have to add a couple words. I'm going to add the word someone, and the word is, and the word a. If someone is a soccer player, then they are an athlete. So I've taken this statement here. This is, you could call this a conjecture. Soccer players are athletes. I think we can agree that if someone is a soccer player, then they are probably an athlete. I guess I'm assuming we're not talking about like a 5-year-old playing soccer with his daycare. I think we can agree that if someone is if I said professional soccer players are athletes here, then you would agree with this statement for sure. So let's assume we're talking about high school and up. If you play soccer in an organized way and you're over the age of 14, you're probably some kind of an athlete. So I would say this statement is true. Soccer players are athletes. We can agree on that. The inverse means I take the negation of both. So, and I think it's in the same order. We can go back and check. Nothing wrong with that. The inverse, right? Looks like the same order, blue then red, but these are opposites of the original. So I'm going to change these from if someone, I'm just going to say if one is not a soccer player, then one is not an athlete. So again, the same order, soccer player, then they're an athlete, but I said not a soccer player, then you're not an athlete. Well, I would say that that is false. There are plenty of people who are not soccer players, but who are athletes. This is false. I'm going to give an example of Tom Brady. Tom Brady is a quarterback for the Tampa Bay Buccaneers. He is a widely regarded as the greatest football player, quarterback of all time. He is definitely not a soccer player, but he is definitely an athlete. So this would be my my counter example right here. I claim it's false, and this is why. I provided you with an example of someone who is not a soccer player. Tom Brady is a football player, and he is an athlete. So it satisfies the hypothesis, but it does not satisfy the conclusion. That is called a counterexample. The converse is you just switch the two statements. You don't change them to the negatives. You just make them in a different order. So I say if one is an athlete, then one is a soccer player. So again, to make the converse, you just switch the hypothesis and the conclusion. So I switched it. I put the athlete part first, the soccer player part second. Soccer player part second, athlete part first. Notice I'm not underlining if and then here, right? And this I think is also false. This says that everyone who's an athlete, this is basically saying if you're an athlete, then you must be a soccer player. And I would use this same example. Pick anyone who's an athlete. Who's your favorite athlete? Doesn't matter. As long as they're not a soccer player. LeBron James is an example of someone who is an athlete but not a soccer player. Babe Ruth was an athlete but not a soccer player. He was a baseball player. So any athlete that's not a soccer player is a counterexample for this statement. And the last one is a contrapositive, which is you switch the order. So athlete first, soccer player second, and I make it negative. If one is not an athlete, then one is not a soccer player. And my claim before was that if this first statement is true, then this statement has to be true. You can look at it, and if you're not an athlete, I don't think you can be a soccer player, at least not in any kind of a meaningful or professional way, which I kind of said at the beginning. We're not talking about 2-year-olds, we're talking about like actual soccer players. And I don't think that if you're not an athlete, you could then manage to also be a soccer player. I can't think of too many people who are not athletes who are soccer players. At least they're not good soccer players. So this is how you would write all 4 of these statements. Again, I had to add a little bit here from this this is just a generic statement. I turned it into a conditional. This is called the conditional. The if then is called the conditional. And then I turned it into the inverse, the converse, contrapositive, all that stuff. And then I can evaluate, I can look at it and say whether things are true or false. Here we got true for the statement and for its converse, and we got false for the inverse. Oh, sorry, let me say that again. We got true for the original statement and true for the contrapositive, but false for the other two. So knowing how to write these is going to be relatively important for you guys. It's not the biggest deal ever, but it is something you should know how to do. And when I say writing these things, what I mean is like knowing how to write, given a statement, how to write the other 3 of these. I'm knowing that the converse is you switch these two, and the inverse is you make them both opposite, and the contrapositive is you do both. So that's it for this lesson. There'll be some practice in class tomorrow. Hope y'all enjoyed it.